In the last video, we have seen what is a graph and types of graphs. And basically, that the graphs are nothing but nodes and edges. Like there are different nodes, and then some of the nodes are connected by edges. Okay. But how this is the diagrams for different graphs. You know, this is an undirected graph, this is directed, and this is directed graph. But how so this whole diagram in itself, this whole diagram, you can represent a graph using two sets, which is a set of vertices. So there's going to be one set which is any graph. Let's say this is a graph G, this is graph G. Then a graph G is represented as two sets, vertices and edges, set of vertices and set of edges. These two sets completely uh, represents one graph. Okay, so vertices, for example, for this set, for this graph G, what are the vertices? So vertices set will have V is equal to A, B, C, D, E, F, G, H, I. These are the vertices in this set. And how the edges are represented means the set of edges. So what are the elements in the set of edges? Every edge is characterized by its endpoints. Okay, so for this edge, the endpoints are A and B. So you can, this edge, how this edge can be there means it's a set of edges. So in it, every element is an edge, and an edge is represented by a pair, which is the endpoints. So A and B is one edge. A and B is one edge. Now, this is not an ordered pair, this is just a pair of elements. You can say it's an unordered pair. For undirected graph, it's an unordered pair, but for a directed graph like this, means the set of vertices are nothing but, V is nothing but A, B, C, D, E, F, G, H, I, but the edges, the set of edges will be, every element in this is a pair which is an ordered pair, because there is a direction to the edge, right? So you can write it as AB. This edge can only be represented with A and B, with A as the first element in the ordered pair and B as the second element in the ordered pair. But in this case, for this graph, this edge is undirected edge. So in case of undirected edge, there is no direction to the edge, and so either you write A or B, A as the first element in the pair, or you may write B and A also. The thing is the same. You may write A comma B, or you may write B comma A. Both are same. But here you can't write B comma A, because the edge is not directed from B to A. The edge is directed from A to B, so you have to write A comma B. So in case of directed graph, the set of edge is set of ordered pairs. Set of ordered pairs where first element of the pair is the source vertex, and the second element is the destination vertex. Source and destination, I should not be using those terms right now, but the first element is that vertex from where the edge is emanating, and the second element of the ordered pair is that vertex where the edge is coming. So A comma B means that an edge is coming from A to B. Similarly, what are the other edges for this directed graph? B comma D, right? A comma C, A comma C. What about this edge? This edge is F comma G. What about this edge? These edges H comma G, H comma J, J comma I comma H. Similarly, for this directed graph, the difference between this directed and this directed is that I have just changed the direction of the edge. So the edge set for this graph So let me give this graph as G2. This is graph G. Let's say this is G1 graph. Okay, G1 graph vertex set is V1 and E1. This is V1, this is E1. Let's say this is G2 graph. This graph is G2, right? And this is E2 and this is V2. Similarly, if this is graph G3, then it is the graph G3 can be given by two sets, what by each set of vertices and by each set of edges. And so V3 is A, B, C, D, E, F, G, H, I, J. A, B, C, D, E, F, G, H, I. And the edge set will be B comma A. B comma A. Notice here it was A comma B because edge was from A to B. Here it is B comma A because edge is from B to A. So A comma B and B comma A is not same because this is a pair of elements. You can say it's a two tuple where the first where it is the pair of element is ordered element, means it's an ordered pair. The order matters. Which element are you writing first and which element are you giving second? Based on that you will decide the direction of the edge. Okay, in case of undirected graph the order does not matter, so you may write A comma B or you may write B comma A. Both are same thing. So B comma A, C comma A, D comma B, G comma F, I comma H, I comma J, J comma I. Sorry, J comma H. Now, just for the future videos on relations, we will start relations now again from once again in the district mathematics playlist. This is going to be video number 18, and we will halt the graph theory part right now, and we will again get back to the relations because as you can see a directed graph the edges are nothing but the set of ordered pairs. So for every relation that you give, what is a relation for any two set A and B? A relation is from set A to B, means we can say that there is a relation from set A to set B. And what are the elements of a relation is the ordered pairs where the first element is from set A and the second element is from set B. So we can say that every relation can be represented as a graph, as a directed graph. Every relation can be represented as a directed graph. Okay, so we will make use of this fact because as simple as that, if a graph is given to you, either the diagram has to be provided, means if you have to know about if there is a question about graph or if someone wants to inquire something regarding the graph, then what is was it what is it that you want to what is it that you will ask first? You will say give me the graph. So either he has to provide with this structure or he has to provide with the set of edges and vertices. From the set of edges and vertices itself you can draw the graph. From the graph you can get this, right? Similarly, if a relation is given to you as a set of ordered pairs, means that you know the first element of every ordered pair is from set A. So those are the vertices in your graph associated with this relation. If in an ordered pair you have first element and second element. So first element that belongs to A. Okay. Let's say okay. I'm erasing this part. If you look at any relation, let's say you have two sets, set A which is 1, 2, 3, and set B which is 4, 5, 6, and let's say R is a relation from A to B such that R is equal to, so R will be a set of ordered pairs, and let me say that 1 is related to 5 and 1 is related to 6, 2 is related to 6, 3 is related to 5. That's it. Let's say this is your relation R. Now, how this relation can be, let's say if this is your relation, okay, what I will be doing, saying, let's say this is your relation. Now what I will be doing is that I am going to use this relation as set of edges. So if this is a set of edges, then you know that vertices are 1, 5, 1, 6, 2, 6, 3, and 5. All of these will be vertices. 1, 5, 6, 3, 2. These are vertices, and the edge will be from 1 to 5. So 1 to 5 there is an edge. 1 to 6 there is an edge. 2 to 6 there is an edge. Then 3 and 5 there is an edge. So this is the graph that is associated with this relation. So if this graph is given, then you can get what the relation is. If the relation is given like this, you can get the graph for the relation. So what are the vertices? Vertices are these elements, okay, and so vertices belongs to A, or vertices may belong to B, okay, and edges is, and the edge set is what? Edge set is your relation, okay. So now we will see in the next video different types of relations, like reflexive relation, symmetric relation, transitive relation, equivalence relation. In the subsequent videos, so we will look at each one of these. Thank you very much.